I hope everyone is doing well. I hope everybody was able to take this weekend to recharge and regroup. We are starting back on Unit 12. We are on day 2, which is half-life and doubling and tripling formulas. So you may have done this in science, and it does go back to science type questions. So when we say half-life, that means that basically you're starting with something, usually bacteria or something like that. And usually what happens is it tells you that there's a bacteria that starts at 10,000 and every 6 days it halves. Okay, so there's a formula for that. So basically the half-life formula we're going to do first. Okay, so the half-life formula. And all it is A equals P parentheses 1/2 raised to the time over the half-life number. Okay, and a good way to remember is that time is always on top. So time meaning if you want to figure out how much of the bacteria is left after 6 years, that would be your time. Okay, so A, just like before, is your final amount. P is your starting amount, so your starting number. The 1/2 always stays in the middle because we're doing half-life. And then your T is your time, and it's divided by H, which is the half-life number. So they'll always tell you that it will take, 6 days for it to half. So they'll always give you the half-life number. Okay, so that's it for half-life. Next we have double and tripling, and doubling and tripling is pretty much the same. Okay, and they're pretty much the same as half-life. So basically the doubling formula, and basically that just means if you have a population that starts at 10,000 and it doubles every 2 days, how many people would there be after 25 days? Something like that. So the number is doubling. And the question will always say that it's either half-life, it'll say doubling, or it'll say tripling. Okay? So double formula is A equals P, again, starting value, times, you now have 2 in the middle that you're timesing it by. And now you are raising it to, again, time over the doubling number. Again, time is what you're solving for. The D on the bottom is your doubling number. So doubles every 5 days, that is your denominator of the exponent. And again, this right here, 1/2 is being raised to this number, so this T over H is an exponent. Same thing here, this whole entire thing is being raised to an exponent of T over D. And then the tripling formula is same exact thing. The only thing is now we have a 3 in the middle. And then time over, now we are using the same variable there because T, time, triple, they both start with the same letter. But again, you just have to remember that the time is on top. And then the big T would be your triple number. Okay? And T, time, on top. I always remember that. So when you're raising it to an exponent, when you're raising it to the fraction, you always want to, whatever your time is, whatever you're solving for, time is always on top. Okay? All right, so I'm going to do number 1 with you. So it says element X is an isotope such that every 94 years, its mass decreases by half. So right there, this is half-life. Given that the initial mass of a sample of element X is 40 grams, how much of the element would there be after 13 years, round to the nearest whole number? So since we're halving and we're doing half-life, I'm going to write down my half-life formula, T over H. So now I'm going to plug in the information. So how much of the element would remain? So that's our final amount. Our P is our starting, so we are starting with Initial mass is 40 grams. So we're starting with 40, 1/2. Now we technically have two numbers that can kind of be time, but remember time is what you're solving for. So every 94 years, it goes down by half. So that's actually your denominator here. That's your H value. So 94 is on the bottom. How much would remain after 13 years? So 13 years, that's the time that you're solving for, that goes on top. So in your calculator now, we have 40 parentheses, 1/2, so I could just put 0.5. And now I'm raising it. Now this calculator is not fancy, so when I raise it to this fraction, I'm just gonna put it in parentheses, which solves the problem. And then I just do 13 divided by 94 and press enter. Okay, so if I'm rounding to the nearest whole number, 36.3 would just round to 36. So A equals 36 grams. Which makes sense because if it takes 94 years for it to half the number, and we're only doing it for 13 years, our number should not be going down by that much. So it went down to 36. Okay. Number 2, you are going to try on your own. So number 2, little giggling in the background. Number 2, you're going to try on your own because that is another half-life question. Let me see, number 3. Okay, so number 3, we are doubling. So I'll do number 3 for you. So number 3 is a doubling question. So now how did I get that quickly? Well, it says 350 bacteria are placed in a petri dish. The conditions are such that the bacterial doubles every 6 hours. How many bacteria would there be after 14 hours? Round to the nearest whole number. So it is a doubling question. So A equals P, parentheses 2, and then time over the doubling number. So A is what we're solving for. 350 bacteria is your starting value, your P value. And then 2 goes in the parenthesis, and now I'm raising it. Now again, the hardest part usually with these questions is figuring out which one is the T or the time and which one is the doubling number. So conditions are that it doubles every 6 hours. That is your D. That is your denominator in this case. How many bacteria would there be after 14 hours? That is what you're solving for. That is your time. That goes on top. Everything matches because everything is in terms of hours, so we're good. All right, so now 350, 2. And now I'm going to raise it to parentheses 14 over 6. So there are going to be 1,764 bacteria after 14 hours. Okay. And hopefully you're able to try the other examples on your own. Okay, and I hope that was helpful, and I hope everybody has a good day, and I will hopefully see you guys very soon. Okay, bye.